Alright, so this video is meant to help you prepare for your Chapter 2 geometry test. That's going to be on Wednesday. My plan is to do 3 problems. I'm going to do 1 algebraic proof, and then 1 segment proof, and then 1 angle proof to get you prepared for all the new proofs that are going to be on your test. There may be 1 or 2 videos, depending on how long this takes me to do. Okay, so let's start with the algebraic proof. Okay, so this will be problem number 1, and this is an algebraic proof. So what it's going to give you, it's going to give you a equation. So it's going to say given, and we'll do this one, 5 parenthesis 3x plus 2, close your parenthesis, equals 25. And I want you to prove that x equals 1. So this is the answer, x equals 1. You just have to show me how you get there, okay? So what you're going to do is you're going to list out your equations. So we'll start with the original, 5 times the quantity of 3x plus 2 equals 25. And this, is, of course, is given to you. So then the first thing you're going to do, and I'll use a different color to show what we do, is you're going to distribute the 5. Okay, so what you will get is 15x plus 10 equals 25, and you distributed the 5, so you use the distributive property. Then the next thing that we will do is we will subtract 10 from both sides. So your next statement would be 15x equals 15, and again you subtracted 10 on both sides, so your reason is the subtraction property. And then lastly, you're going to go ahead and divide both sides by 15. When you do this, you will get x equals 1. And your last reason here, what did you do? You divided on both sides, so it's the division property. Okay. Alright, and there is the algebraic proof for this review. Next, let's move on to a segment proof. I'm going to write it down while I pause it, so make sure you write it down as well. Okay, so again, I paused it, so you should have this copied down. So right now, you should pause and write this down on your paper. All right, so after you come back from your pause, we're going to go ahead and talk about the proof. All right, I will use a different color to fill in the statements and reasons. Now, again, we always start with the given as our first statement. So we have segment AE is congruent to segment BD. And we also know that segment CD is congruent to segment CE. Okay? And this was given to us. So you always have to keep in mind what you want to prove. You want to prove this statement. Okay? So first of all, let's mark down what we know. We know that AE, the entire segment, is congruent to BD, the entire segment. That's very hard to mark. I'm going to put it right here and right there. That's for the entire segment. Okay? And I also know that CD is congruent to CE. So I'm going to put 2 on CD and 2 on CE. So now we have to prove that AC is congruent to BC. Alright, so let's first use the segment addition postulate. Okay? Whenever you have segments broken up into different segments, smaller segments, use the segment addition postulate. So let's start with what do we have? AE. Let's start with AE here. Here's AE. AE is composed of AC plus CE. So let's write that down. AE equals AC plus CE. And we'll do the same thing for segment BD. BD is made up of BC plus CD. Remember that your segment addition postulate is going to probably be used in all of your segment proofs. I'm going to use shorthand just to speed up the video. Segment addition postulate. Okay, so now it would be nice to combine steps 1 and 2, but Step 1 is incongruence. Step 2 is inequality. We can't combine them until we get all the same. So let's bring these congruences into equality. So we will say that AE is equal to BD, and that CD is equal to CE, and that's going to be by definition of, and I'm going to put the little symbol, congruence. Feel free to use this on the test, okay? Those little symbols. Alright, so now, if I look at what I have, look at this statement right here. I'll put it in yellow. I see AE up here, and I see BD right here. What I'm going to do is I'm going to do a substitution. I'm going to substitute these sums in for AE and BD. Because look, I want AC and BC to be in the same equation. Right now, AC is in this equation, BC is in this equation. I want them to become together, so if I substitute into the single equation, I'll get AC and BC together. So we're going to do a substitution. Again, AE comes out, AC plus CE goes in its place, BD comes out, BC plus CD goes into its place. And we just simply did a substitution. Now, we want AC and BC to stay, because we need to show they're equal so we can show they're congruent. So we want CE and CD to be gone. Well, the only way to get something gone from both sides is if it's the same thing. Well, look at this. Look right here. We know that CD is equal to CE. So let's take CE out from right there and put CD in its place. Let's do another substitution. So we get AC. Now the CE comes out and the CD goes in its place. Plus CD equals BC plus CD. And again, this is by another substitution. I need to scroll down here a little bit. Okay. So let me extend the line. Okay. So now, look what we have on both sides. We have AC plus CD equals BC plus CD. Let's go ahead and let's subtract the CD from both sides using the subtraction property. So we get this next step that says AC equals BC. And what we do, we use the subtraction property. And finally, if AC is equal to BC, we can show that what we want to prove. We can show that segment AC is congruent to segment BC, and that is by the definition of congruence. When you go from equality to congruence and back and forth, it's the definition of congruence. Okay, so I'm going to keep going. Okay, this is 8 minutes. Well, it will be less than 15 minutes. I did want to show you one thing. For those of you who watched the video, there's going to be a bonus question on your test Wednesday. And this bonus talks about what did Mr. Chappell say was the bonus. Okay, we are going to start flipping the classroom in this class. So your bonus is the phrase "flip the classroom." If you remember this for your test, you'll receive 2 bonus points. So don't forget that. Flip the classroom. And you're going to receive some information tomorrow about us doing this flip the classroom. And we're going to start it after this chapter test. Alright, so remember that, flip the classroom. Okay, again, I'm going to pause and write the next proof down. And then I will come back to you. Okay, so I've returned. Here is your next proof. Here's this picture. We're given that angles 1 and 2 are complementary, angle 3 and 4 are complementary, angle 1 and angle 3 are congruent, so we want to prove that angle 2 and angle 4 are also congruent. Okay, so the first step is always the given. So angle 1 and angle 2 are complementary, angle 3 and angle 4 are complementary, and then angle 1 is congruent to angle 3. Alright, and that's given to us. So let's take these first 2 statements the fact that the angles are complementary, and let's write what it means to be complementary. The definition of complementary angle says that the two angles add up to 90 degrees. So the measure of angle 1 plus the measure of angle 2 equals 90 degrees. The measure of angle 3 plus the measure of angle 4 equals 90 degrees. And this is again by the definition of complementary angles, of comp, and then I use the angle symbol, angles, okay? And again, feel free to use this shorthand on your test. So then, what can we do? Well, look what's the same. They're both equal to 90 degrees. If they're both equal to 90 degrees, then the sums are equal. We can take this one right here and plug it in up here. And that's what we're going to do. So we're going to write that the measure of angle 1, we're going to leave that part alone, plus the measure of angle 2 equals. And now we're not going to put 90, we're going to put this sum in its place. The measure of angle 3 plus the measure of angle 4. And that's by a substitution. Now again, always keep in mind what you want to prove. You want to prove 2 and 4 are congruent. That means angle 2 and angle 4 need to hang around, so maybe 1 and 3 can disappear. But just like the last proof, 1 and 3 have to become the same. It has to be 1 and 1 or angle 3 and 3. Well, look at what we haven't used yet in the given. We haven't used this fact yet. If we mark it, angle 1 is congruent to angle 3. All right, if we mark it, then we can maybe see that angle 2 and angle 4 should also be congruent. But how? Well, first of all, if we want to bring this angle 1 and angle 3 into the equation, we need to get it in terms of equality. So let's do that first. So that means that the measure of angle 1 equals the measure of angle 3. And that's just directly from here. That's by the definition of congruence. Okay, so let me slide down a little bit. That should be good enough. So now we could take out something in statement 3. Let's take out the measure of angle 1. And since measure of angle 1 equals measure of angle 3, let's put the measure of angle 3 in its place. So now we will get the measure of angle 3 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. And we did a direct substitution, so that's by substitution. And now look what we can do. On both sides there's a measure of angle 3. Subtract it away. So we subtract that away to get that the measure of angle 2 equals the measure of angle 4. That was a subtraction property. We subtracted on both sides. So finally, if the two angles' measurements are the same, then they are congruent. Angle 2 is congruent to angle 4, and that is by the definition of congruence. Okay? And there's your angle proof. So make sure you use those complementary and supplementary words correctly. Remember the vertical angles and the angle addition postulate. Okay? All right, so thanks for watching, and we'll see you on Wednesday.